Alright, so this time we're doing absolute values, and what we're specifically going to do is we've stepped it up from the previous absolute value ones. We're still going to write this expression without absolute values, but now we have a variable x in there, and x is free to range over the entire real numbers because we have no division or even nth roots. So essentially I have to find out when this is true. So again, we go back to what are we really asking. If I want to strip the bars off of this absolute value or free him from the absolute value prison that he's currently in, what do I have to do? All I need to know is when is that positive or negative is what we're really asking. I need to know, is it positive, greater than or equal to 0 or less than 0, and right now we don't know. So what I do is we're going to write equals just like the basic definition, but I don't know yet. So it's going to be itself when that thing is positive, or it's going to be the negative of itself. That's the only two options for what this could be, but I have to find out when that's true. I have 2x plus 1. Let's look at the first inequality separately. When is this true? Well, I've got rid of the absolute value, and I'm just trying to find out when this thing is positive, and by default, coincidentally, because it's linear, it'll also tell me when it's negative. So solving this will tell me exactly when this expression is positive, and then it will tell me x values for which I can write absolute value is just equal to this. So starting with an inequality, I can subtract 1 from both sides and it won't change the order of the inequality. So that's what we're going to do first. We're going to subtract 1 from both sides. Doing that, I get 2x is greater than or equal to negative 1. The 1 and the minus 1 cancel, and 0 plus negative 1 is negative 1. The next thing I'm going to do is I want to multiply by 1/2 to isolate x. 1/2 is greater than 0, so it won't change my inequality. So I do that, and that says that x is greater than or equal to negative 1/2. So notice what that's told me is, you can do if and only ifs. 2x plus 1 is greater than 0 if and only if x is greater than negative 1/2. And coincidentally, what that will say is 2x plus 1 is less than 0 if and only if x is less than 1/2, negative 1/2. So now we have both conditions. So however you organize that, but I like to do it as a side calculation or do it ahead of time. They had absolute values on an expression involving x. I find out when that thing is positive or negative separately, and now I can put this together to write out exactly what we have. 2x plus 1 in absolute value is equal to 2x plus 1 if 2x plus 1 is greater than or equal to 0, and that's going to be if and only if x is greater than or equal to negative 1/2. I'll clean that up in a second and write it as the final answer. And it's equal to negative 2x plus 1, the negative of itself, if 2x plus 1 is less than 0, which we saw was if and only if x is strictly less than 1/2. So you can actually build the inequalities. What it's asking is, this is equal to itself if that thing is positive, and then you just solve for x in the inequality. I did it separately at first to show you how to do that. And then it's equal to its negative if and only if this is negative, and I solve for the inequality, and this is what I get. So with the magic of editing, the absolute value of 2x plus 1 is equal to 2x plus 1 if x is greater than or equal to negative 1/2, and 2x plus 1 is equal to negative 2x plus 1 if x is less than 1/2.